Hi students, we are seeing finite element analysis. In this, already we have completed 3 units. This is our 4th unit where we have axis-symmetric elements. So I am Thamarai Selvan for the Department of Mechanical Engineering, Savitha Engineering College. And the contents in this session are the axis-symmetric element, what is that axis-symmetric element and its applications. Then the finite element equations which we require for solving the axis-symmetric problems, which includes the stress-strain relationship matrix, strain displacement matrix, stiffness matrix and force matrix. Well, now let us see what is axis-symmetric element. See, these axis-symmetric elements are triangular tori such that each element is symmetric about certain axis. See, in this case, this object is symmetric about Z. So when you call this as symmetric, when their loading condition, their geometrical conditions and their material properties are symmetric about or equally spread on either side of this axis. So this Z axis is the axis of symmetry here, and each vertical section of the element is a plane triangle. Suppose you consider a small element here, say IJM, then this would be a triangular element as we have CST element in the previous chapter. And the nodal displacement of the axis symmetric elements can be described on the circumferential lines. In the next slide we can see. Okay, this axis symmetric problems mostly solved by these plane stress problems. These are the plane strain problems. The stresses exist only in xy plane. We consider the Z as the axis of symmetry. Hence, we'll go with the plane x and y. So, in axis symmetric problems, the radial displacements develop circumferential strains that induces stresses in sigma r, sigma theta, and sigma Z. So these are the direct stresses along the radial directions, the theta direction and also the axis Z direction. And this tau RZ is the shear stress along the RZ plane. In XYZ we will say XY plane, here it is RZ plane, where R, theta and Z indicate the radial, circumferential and longitudinal directions respectively. These triangular torus elements are often used to idealize the axis symmetric system because they can be used to simulate the complex surfaces in these type of problems. Let us see some of the applications of this axis symmetric elements. In this figure, you just see how this object is symmetric about Z axis. Similarly here it is symmetric about the vertical axis. So here it is discretized and it is solved using software algar. But this type of objects can be easily solved by this axis symmetric problems. And here it is shown a barrel, a cylindrical barrel, where the distribution of the pressure inside this barrel is shown by this after analyzing using a software. So for instance, the axis symmetric problem of the stresses acting on the barrel under an internal pressure loading. So here the pressure exists inside this cylindrical barrel. So that distribution of the pressure intensity is shown here. And this is another object which is an engineering application where it is symmetric about the axis. Like this, we have several applications in axis symmetric problem. Coming to the stresses in the axis symmetric elements. So as we already saw, we have 3 direct stresses and 2 direct stresses and 1 shear stresses, and we also have the shear strains. Okay, so just to recall the basic procedures and what are the fundamental basics needed for this for solving these axis symmetric element problems. This we will continue in the next class. Thank you.